Worksheet number 6, Thermochemistry. Question number 1. Calculate the approximate amount of heat necessary to rise the temperature of 50 grams of liquid water from 10 Celsius to 30 Celsius. The specific heat of water liquid is 4.18 joule per gram Celsius. So the amount of heat, the rule of heat is energy as heat equal specific heat times mass times change in temperature. So here you have 50 grams of water, this is the mass, and temperature increases from 10 to 30, so delta T equal 20 Celsius, and specific heat of water is 4.18. So you have the specific heat, you have the mass and change of temperature, so you can calculate the energy. So which is equal 4.18 times 50 times delta T 20, which is equal 4.18 times 50 times 20, 1000. So here you have to move the decimal 2 units. So the answer is 418 times 10, which is equal 4180. So the answer is E. Now, question 2. According to the reactions represented above, what is the enthalpy of reaction? So if you have chemical reactions and you want to get the enthalpy for this reaction, you have to rearrange the reactions here to get this reaction, and any change of these reactions, delta H changed. So here XY2 liquid is in the reactant side, so here XY2 liquid in the reactant. So here in this reaction, don't change the reaction. Then XY2 liquid equal XY2 gas. Here X and Y2 are in the product side, and here X and Y2 in the product. So also this reaction, don't change anything of this reaction. So XY2 gas produced X plus Y2 gas. Here delta H for this reaction minus 60, and here delta H 25. So if you add these reactions to each other, so here XY2 gas in the product, and here XY2 gas in the reactant, so you can delete it. So XY2 liquid produced X gas plus Y2 gas. So here you get this reaction. You add these reactions to each other, so also you have to add delta H to each other. So here delta H equal 25 plus negative 60. So the answer is negative 35. So the correct answer is D. Now, in an exothermic reaction, the energy stored in the chemical bonds of the reactants is exothermic reaction. And here the question asks about the energy of reactant. You have to remember that in exothermic reaction, the energy of reactant greater than energy of products. So the energy of reactant greater than the energy stored in the bonds of products. So the answer is B. Now question 4. A process that absorbs heat. Absorbs means the reaction need energy to occur. So it's the definition for endothermic reaction. Question 5. The quantity of heat required to change the temperature of 1 gram of substance by 1 Celsius is defined as. So this is the definition for specific heat. So the answer is C. 6. What is the amount of heat required to rise the temperature of 200 gram? So here this is the mass of aluminum by 10 Celsius. So here delta T. And the specific heat of aluminum is 0.9. So here the specific heat. You have mass and delta T and specific heat, so you can calculate the energy as heat. So Q, energy as heat, equals specific heat times mass times delta T, which is equal specific heat 0.9 times mass equal 200 times delta T 10, which is equal 0.9 times 2000. So 2 times 9, 18. You have 3 zeros here. And you have decimal. So the answer is 1800. So the correct answer is C. Question 7. Which of the following is valid unit for specific heat? What is the unit for specific heat? Energy as heat equal specific heat times mass times delta T. So over mass times delta T over mass times delta T. So specific heat equal energy over mass times delta T. So the units for energy joule over for mass gram times for temperature Celsius or Kelvin. Here all the examples you have Celsius. So which of these joule per gram times Celsius? So the answer is E. 8. The specific heat of silver is 0.24. How many joules of energy are needed to warm 10 grams of silver from 25 Celsius to 27 Celsius? So here you have the specific heat. How many joules of energy you need to calculate Q. Here the mass, 10 grams, and delta T from 25 to 27 to Celsius. So Q equal specific heat times mass times delta T, which is equal specific heat 0.24 times mass 10 times delta T 2, which is equal 2 times 24, 48. You have 0 here, and decimal after 2 units, 1, 2. So the answer is 4.8. So the correct answer is B. Question 9. The amount of heat transferred from an object depends on which of the following? So amount of heat transferred, it's equal specific heat times mass times delta T. So amount of heat depends on the specific heat and mass and change in temperature. So A, the specific heat, yes. The mass of the object, yes. The initial and the final temperature of the object, yes, to get delta T. So all of the above. Question 10. What does the symbol delta H stand for? Delta H, it's for enthalpy of reaction, and enthalpy means energy. So it's for energy of reaction or enthalpy of reaction. So here, energy as heat, okay. So the specific heat, no. The heat capacity of substance, the heat of chemical reaction, yes. So the answer is C. Question 11. What is delta H for the reaction Cl2 plus 2HBr to produce 2HCl plus Br2? You have here two reactions. The idea is you have to rearrange these reactions to get this reaction, and any change of these reactions, delta H changed. So here Cl2 is in the reactant, and here Cl2 in the reactant, so don't change this reaction. Cl2 plus hydrogen gas to produce 2HCl. Delta H minus negative 185. Now here, Br2 is in the reactant, but here in this reaction, Br2 in the product. So you have to reverse this reaction. So 2HBr decomposed to bromine and hydrogen gas. Delta H equal. If you reverse this reaction, so you have to change the sign of delta H. So here positive 73. Now if you add these reactions to each other, here you have hydrogen in the reactant and hydrogen in the product, you can delete it. So Cl2 plus 2HBr produced 2HCl plus Br2. So you get this reaction. So here you have to add. So delta H equal plus 73, which is equal minus 112. So the answer is B. Question 12. What is delta H for the reaction carbon plus oxygen, carbon dioxide? The same idea. You have to rearrange these reactions to get this reaction, and any change of these reactions, delta H changed. So here carbon is in the reactant, and here carbon in the reactant. But here you have 1 mole of carbon and in this reaction you have 2 mole of carbon. So the first step, you have to divide this reaction by 2. So if you divide by 2, 2 over 2, okay, 1 mole of oxygen, 1 divide by 2, half. Two by 2, 1. So here delta H equal. If you divide this reaction by 2, so you have to divide delta H by 2. So negative 110. Now, carbon dioxide here in the product, and here carbon dioxide in the product. But here you have 1 mole of carbon dioxide, but here 2 moles. So also you have to divide this reaction by 2. So 2 over 2 CO plus 1 mole divided by 2, half mole of oxygen to produce 2 over 2, 1 mole, so CO2. So delta H equal. If you divide this reaction by 2, so delta H also divide by 2, which is equal 283. So now if you add these reactions to each other, carbon dioxide here in the product and here in the reactant, you can delete it. So carbon plus half mole of oxygen plus half mole of oxygen, 1 mole of oxygen to produce carbon dioxide. So now you get this reaction. So here you have to add. So delta H equal negative 110 plus negative 283, which is equal negative 393. So the answer is B. Now the last question. What is delta H for the reaction? For ammonia gas plus 5 moles of oxygen to produce 4 mole of nitrogen monoxide plus 6 moles of water. Also the same idea. You have to rearrange these reactions to get this reaction, and any change of these reactions, so delta H changed. Here an H3 is in the reactant, and here an H3 in the reactant. But here you have 4 mole and here 2 mole. So the first step, you have to multiply this equation by 2. So 4 ammonia, 4 mole of ammonia plus, decomposed 2 mole of nitrogen and 6 mole of hydrogen. Delta H equal. Here you multiply the equation by 2, so you have to multiply delta H by 2. So 92 by 2, which is equal 184. Now, nitrogen monoxide here in the product, and here nitrogen monoxide in the product. But here you have 4 mole of nitrogen monoxide, and here you have 2. So you have to multiply this equation by 2. So 2 mole of nitrogen plus 2 mole of oxygen produced 4 mole of nitrogen monoxide. So here you multiply the equation of the chemical reaction by 2, so you have to multiply delta H by 2. So delta H equal negative 180 by 2, which is equal negative 360. Now here H2O is in the reactant, here H2O in the H2O in the product, and here H2O in the reactant. So the first step, you have to reverse this reaction. Two mole of hydrogen plus oxygen to produce 2 mole of water. Delta H equal, here the sign is positive, you have to change the sign, so negative 572. Now water is in the product, and here water in the product, but here you have 6 mole of water and here you have 2 moles of water, so you have to multiply this equation by 3. So 6 moles of hydrogen plus 3 moles of oxygen to produce 6 mole of water. So delta H, if you multiply by 3, here you have to multiply by 3. So the answer is 1716. Now if you add these reactions to each other, here 6 mole of hydrogens in the product and here 6 mole of hydrogen in the reactant, you can delete it. And here you have 2 mole of nitrogen in the product, and here you have 2 mole of nitrogen in the reactant, you can delete it. So now 4 mole of ammonia plus 2 mole of oxygen plus 3 mole of oxygen, so 5 moles of oxygen produced, 4 mole of nitrogen monoxide plus 6 mole of water. So now you get the reaction. So here you have to add. So delta H equal 184 plus negative 360 plus negative 1716. So delta H equal negative 1892. So the answer is